Hi and welcome to Chemipedia chemistry classes for 11th and 12th standard. So in this video I am going to discuss a simple trick to find period number and group number of an element whose atomic number is known. From the atomic number of the element we are able to find out period number and group number. So following certain rules. The first thing, you are supposed to know the complete electronic configuration of the element whose atomic number is given. Then after writing the electronic configuration, look at the highest principal quantum number value, highest n value in the electronic configuration. That number is nothing but the period number. Similarly, let us see how to find out group number of the element. So before we go to that, so after writing the electronic configuration, first you have to predict in which block that element belongs to, based upon the nature of valence electron. If the valence electron is present in s orbital, it belongs to s block. Likewise, if it is p or d, in the sense it may come under either p block or d block, isn't it? Right. F block I will discuss later separately. Right. Now, so after writing the electronic configuration, you are looking at the valence electron. The valence electron is present in s orbital. If it has s1 configuration or ns1 configuration, then the group number of that element is 1, or it is nothing but 1a group, which is nothing but alkali metals, isn't it? Similarly, if the valence electron is in the s orbital and there are 2 electrons in the s orbital, which means if it has ns2 configuration, then that element will belong to group number 2 or 2a, which is nothing but alkaline earth metal, isn't it? Then suppose if the valence electron is present in the p orbital, then so now what you have to do is you have to add the s electron number with the p electron number. Along with that, you have to add a number 10 also. So the formula is nothing but number of s electrons plus number of p electrons plus 10. For example, an element has valence electron configuration ns2 and p5. So number of electron in s orbital is 2. Number of electron in p orbital is 5. So I am adding 2 with the 5 plus a number 10. So I am getting about 17. So which means that element with this valence electron configuration may belong to group number 17. Okay. Then the third category, D block. So for finding the group number in case of D block elements, if the valence electron is in D orbital, to find group number, we are supposed to add the number of s electrons as well as number of d electrons of that element in the valence configuration. Okay, the summation of number of s electron and d electron will give the group number of d block elements. Okay, right. So let us see some example for that. I repeat the steps what we are supposed to follow. Okay, first we are writing the complete electronic configuration and we are noting down the highest n value. That highest n value is nothing but its period number, isn't it? Then note the nature of valence electron. If it is an s electron, so you know that it belongs to s block. If it is ns1 type configuration, so it belongs to group number 1 or 1a, Roman number 1a, which is nothing but alkali metals, isn't it? Similarly, valence electron is in s orbital. It has s2 configuration or ns2 configuration, so group number 2 or Roman number 2a, which is nothing but alkaline earth metal, isn't it? So this is how to find the group number of a s block element, isn't it? So same thing you have to do for even p and d block also. Let us see some examples. Okay, right. So the first question, number 1, an element with atomic number 19. An element with atomic number 19. So find out the group number and period number of that element. Okay, right. So now using the atomic number, so I am writing the complete electronic configuration. So this is the complete electronic configuration. So I am looking at the highest principal quantum number. So it's nothing but 4, isn't it? These numbers what are written before orbitals are nothing but principal quantum numbers. The highest principal quantum number is 4. So this element belongs to period number 4. Period number 4. Okay, right. Then the highest n value is 4. So period number is 4. Now, so look at the valence electron. It is in s orbital. So it belongs to s block. Then the electron number in s orbital is 1. NS1 configuration, so group number 1. So that element with atomic number 19 belongs to period number 4 and group number 1 or group number 1A. Okay, right. Then the other next example. Atomic number 15. So period and group number, you are supposed to find it out. Okay. So this is the complete electronic configuration with atomic number 15. So highest n value is about 3, isn't it? So that this element belongs to group number 3. Right. So look at the valence electron. It's a p electron. So this element probably belongs to p block. So that to find out group number, the formula is number of s electrons plus number of p electrons plus 10, isn't it? S electron number is 2. P electron number is 3. So 2 plus 3 plus 10. So it's about 15. So this element comes under group number 15th group, okay, or 5B groups. Okay, right. The next question, you are given the general electronic configuration of an element. It is NS2, N-1, D3 configuration. So they are asking to identify the group number. And now look at the valence electron. It is D electron. So the element with this configuration may belong to D block, isn't it? So that the formula for identifying group number in case of D block, number of S electrons plus number of D electrons, that is NS electron number plus N-1D electron number. Whereas here in the general configuration there are 2 S electrons and 3 D electrons. So NS electron number 2 plus D electron number 3, so which is equal to 5. So that the element with this configuration probably belongs to group number 5. Correct. Now look at question number 4, which is different from the previous questions. Here you are given group number and period number, and they are asking to identify which element is that one. Okay, and you are given 4 options: silicon, carbon, germanium and tin. You have to find the right option. Okay. Now what is given there? Period number 3, group number 14, isn't it? Right. So period number 3, so principal quantum number is about 3. The highest principal quantum number is about 3. Then the options whatever given here, all the 4 options are belongs to P block, isn't it? So probably these elements may have an electronic configuration of NS-NP configuration. They may have NS-NP configuration. Okay, and you are given group number 14, which is nothing but summation of NS electron, NP electron plus 10, isn't it? So sum of that NS plus NP plus 10 is equal to 14. So all these belongs to P block, so that S orbital is fully filled. So the number of electron in S orbital is about 2 plus P orbital electron we don't know, isn't it? Plus 10 is 14. Now you are getting about 12, so that P electron number will be about 2. So that this element probably has 3s2 3p2 configuration. 3s2 3p2 configuration, then only it can belongs to group number 14, isn't it? Right. So group number 14 is nothing but carbon group. So carbon is having the valence configuration 2s2 2p2. Just below carbon you have silicon, which has 3s2 3p2. So the element with this 3s2 3p2 configuration is nothing but silicon, or otherwise the element which belongs to period number 3 and group number 14 is nothing but silicon. Okay, right. So next, let us move to the next question. Question number 5. An element with atomic number 120. What will be its electronic configuration, group number and period number? Right. Now, so these are the inert gases what we have in the modern periodic table: helium, neon, argon, krypton, xenon, radon. The last one is nothing but organization, isn't it? With their atomic number 2, 10, 18, 36, 54, 86 and 118. And you know the difference also. Okay, 2 plus 10, 8, 18, 8, 8, 8, 18, 18, 32, 32. Okay, right. Now the element given here has atomic number 120. So you just find out the nearest inert gas. The nearest inert gas is nothing but organization with atomic number 118, isn't it? Just subtract that element atomic number from the given atomic number. 120 minus 118. So you are getting 2. So which means this element given here has 2 extra electrons than the inert gas, nearest inert gas organization, isn't it? So that the 2 extra electrons are supposed to be in S orbital, because after the inert gas, now we come to the first portion of periodic table, which nothing but S block, isn't it? So that 2 extra electrons are supposed to be in s orbital, so that this element may have ns2 configuration, isn't it? It's nothing but actually 8s2 configuration. So this element belongs to period number 8. So the principal quantum number is highest principal quantum number may be 8. So it belongs to period number 8. Then S2 configuration, isn't it? So that it may belong to group number 2. That is second Neo group, which is nothing but alkaline earth metal. Okay, right. So the element with atomic number 120 belongs to group number 8 and period number 8 and group number 2. Okay, and probably the electronic configuration can be given as O Ganeshan, electronic configuration of inert gas O Ganeshan, which is followed by 8s2 configuration. Okay, right. Then the next question number 6. An element with atomic number 56. For that you have to find out period number, group number and electronic configuration. Okay, right. So for this, for finding period number, group number, so as I discussed already, you are supposed to write the complete electronic configuration. So it is little bit difficult for writing electronic configuration of higher elements, so that for them we are following a different method. Okay, right. Now find out the nearest inert gas for this element. Okay, so nearest inert gas is nothing but xenon with atomic number 54. So subtract the inert gas atomic number from the given atomic number 56 minus 54. So this element has extra 2 electrons, isn't it? So it has extra 2 electrons than xenon. So extra 2 electrons probably supposed to be in the s orbital, isn't it? So the 2 electrons are supposed to be in ns orbital. So it has ns2 configuration, the valence shell. That is nothing but 6s2, because xenon has the configuration 5s2 5p6 in the valence shell. So that this is having 2 extra electron, so that electron is supposed to be in 6s orbital, 6s2 configuration. So this element belongs to s block, 2 electrons in s orbital. So second group, 2a group, alkaline earth metal, and the electronic configuration is nothing but the nearest inert gas xenon configuration followed by the extra 2 electron in the 6s orbital. So xenon 6s2 is the electronic configuration of this element. Okay, right. So the element belongs to group period number 6, group number 2. Okay, right. Then the last question number 17. Atomic number is given about 35. So as usual, period, group numbers and electronic configuration. So the nearest inert gas for this one is krypton with atomic number 36. Now see the difference in electron number between these two. Krypton 36, given element 35. So the given element has 1 electron lesser than the krypton inert gas, isn't it? So that this element is supposed to come just before the inert gas group, isn't it? Right. So inert gas group belongs to 18. So this is supposed to be before the inert gas. In the sense, this element is supposed to belong to group number 17. So group number 17 is nothing but halogen, isn't it? Right. But now inert gas is nothing but krypton, isn't it? So krypton is having valence configuration 4s2 4p6. So this element is supposed to have 4s2 4p5 configuration. So from this you can understand what is the highest principal quantum number, which is nothing but 4. So that the period number of this element is 4. Now we come to the group number. So group number already, so just before krypton, so it belongs to 17th group. No doubt about that. So let us prove that with the formula also. Okay, group number is number of s electron, p electron and 10, isn't it? Sum of s electron, p electron and number 10. So s electron number 2, p electron is 5 plus 10, so 17. So that element is coming under the group number 17. Okay, right. Now let us see how to find period and group number for F block elements. So actually in F block there are 2 rows, isn't it, which are placed at the bottom of periodic table. The first row elements are called as 4F block elements, starting with cerium with atomic number 58 and ending with Lu, lutetium with atomic number 71, isn't it? The second row elements are called as 5F block elements. The first element is thorium with atomic number 90. Then the last element Lr, lawrencium with atomic number 103. Right. So actually these are placed separately at the bottom of the periodic table, but they are supposed to be in the original periodic table after lanthanum and actinium. So this cerium to lutetium, this is the original periodic table. Here we have lanthanum with atomic number 57, that element 14 element, that is cerium to lutetium, is supposed to come after this. Cerium with atomic number 58 and lutetium with atomic number 71 is supposed to come between lanthanum and hafnium, isn't it? Similarly, the second row 5 block, thorium atomic number 90, it has to come after actinium with atomic number 89. Then the last element lawrencium 103. So that atomic number 90 to 103 is supposed to be between these two elements, that is actinium and rutherfordium. Okay, so this is the actual position of the two rows of F block, that is 4 F block element here, then 5 F block elements are supposed to be placed here, isn't it? Okay, right. Now so look at the group number. So this lanthanum actinium belongs to group number 2. Group number 3, isn't it? Therefore, that 4F block as well as 5F block elements group number is nothing but the same. They belongs to group number 3 or 3A. Whereas period number, so the first row 4F block elements period number is about 6. Lanthanides are having period number about 6. This is 7th period, isn't it? So probably the actinides are getting period number 7. Okay, so that is how to find out the group number, period number for F block elements. Okay, right. So we have a common group number with different period number for 4F and 5 block F block elements. 4F block element cerium to lutetium, group number 3 or Roman number 3A. 5F block the same number, isn't it? Group number 3 or 3A. Whereas period number 4F block lanthanides, it is about 6. Whereas for actinide it is about 7. Okay, right. So this is a very simple way to find out period and group number for elements whose atomic number is given. Right. Thank you.